We'll start by looking at the importance of data tables. Perhaps you want to answer a question like this. Has the number of private elementary and secondary schools grown over time? What about minority enrollments in these schools? How many college degrees were given in each of the past several years? And how were these degrees divided among fields of study and by the age, race, and sex of the student? These are all questions that can be answered by looking at the educational section of the statistical abstract that's made available publicly online. We don't necessarily want to see the information on every college degree individually. We're interested in the number of overall degrees that fall into each category, as well as the percent. So we can make a clear table by clearly labeling what each column is representing. The category that the data represents, the frequency or the number, and notice here that this is in thousands simply because there's so many students in college, there's so many people aged 25 years and over that we don't want to have such large numbers. So we can just count by thousands, and if your numbers are even bigger, you can count by millions if that makes the data a little bit easier to observe. But what's important here is we look at the percent, and that clearly helps us make a distinction between the different groups. We clearly see that 10.4% of people aged 25 and over have less than a high school education. 28.8%, their highest degree earned was a high school diploma. And so you can see these percentages will add up to 100%, or at least something close to 100%. Occasionally there are some rounding issues. One thing that's nice about a clear table is that you have these clear labels and you're able to very quickly and all at once observe the distribution of the data. Now, what we're going to talk about is this idea of a distribution. So the distribution of a variable tells us what values that it takes and how often it takes these values. That's what we're showing in a data table. You can show the rates, such as percentages and proportions. You can also show the counts, but it's typically clearer to show those rates, and that helps us very easily make comparisons. Quick note here is that you could have round off errors, and here, since the number of people were measured in thousands, we are actually losing some of the additional place value here, and so the rounding that happened overall caused the final answer to be a little bit different than what the actual population was. And so in this case, just be cautious that when numbers don't add up, it's not necessarily because you are being misled. Sometimes that is the case, but other times it's just a rounding issue. It's not uncommon to see these round off errors that happen in tables. If you have something that's close to 100% when you add up your frequency, or when you add up your percentages, as long as it's really close to 100, there's probably nothing incorrect going on. 99.9, 100.1, it's not uncommon to see numbers like that. If the numbers are significantly different from that, then you need to consider that there were some arithmetic issues that happen in the data. I spoke about these levels of education as being categories. And so we have two different types of variables that we're going to be considering in this class. And it's helpful when you're coming up with the appropriate graph to know what type of variable it is that you're trying to display. Variables that place an individual into one of several groups or categories is called a categorical variable. On the other hand, a quantitative variable is going to take numerical values for which arithmetic operations such as adding or averaging make sense. You have to be careful here. A quantitative variable does not necessarily have to be all of the numbers. Occasionally you will have numbers that are actually categorical variables. Think about things like your zip code. That zip code is just placing you into a geographic region of your county. So that information, even though it is a number, it's more a category because it's putting you into a group. Your student ID number is a number, but it's really just an identifier. And so it's putting you into a category of 1, but it's still a categorical variable. One other common instance of a number that's actually a categorical variable would be the jersey numbers for athletes. Those numbers, while they sometimes give you some insight into what position a player might play, the numbers themselves really don't have any numerical meaning. And so therefore, they would be a categorical variable. When you have categorical variable, you often will see a pie chart or a bar graph used to display that information. So we can take the data from the education table and we can turn it into a pie chart where each section represents a proportional section of the circle based on the percentage that that category takes. So you can think of a pie chart as showing the whole divided into parts. If you need to make one of these by hand, you would draw a circle, and that's going to represent the whole. Each wedge is going to have an angle that's proportional to the size of that part. We really like pie charts when we're trying to see how the parts make up the whole. However, pie charts can be problematic because it's actually easier for our eyes to compare the heights of bars on a bar graph than it is to compare the size of angles on a pie chart. So pie charts are used not quite as frequently because they are harder for people to interpret visually. The same information can be shown in this bar chart. And here you see that it is easier for your eyes to see the differences between the groups versus the pie chart that's shown like this.